I'm going to get into is just some new studies. Primarily, Matt and me have kind of like my work with Matt has been with irrigation pivots, different irrigation systems on those that Tina and Matt talked a lot about. Tina and Boyd rather. This year we've gotten into some new flood irrigation stuff where we're looking at some surge irrigation, and if you're new to that, I'll explain that briefly. We're looking at maybe some different scheduling changes, and aside from that, we're also trying out a little new technology. When we get through talking about that, I'll tell you about a new little study we started up, just trying to improve the wheel tracking on pivots. So we'll start. We'll head to Corinne and hear from this guy.
Hey everyone, we're out here in Corinne now, standing in an alfalfa field. This is one of the sites that we're doing some flood irrigation research in. Recently, there's some land leveling that happened. They had some ditches put into pipe, and along the head of the field here, you can see we've got these alfalfa valves about every 15 feet. So pretty good scenario for doing some of this research on. The things we're testing is a year of continuous flow, where basically the farmer comes, opens this set and fills it till it gets to the other end, shuts it off and moves to the next set. So that's what's happening here this year versus next year, where he'll be set up to do surge flow. And we're doing a lot of different measurements with the water, including some soil moisture testing stations that we have along the length of the field. And that's going to help us understand the uniformity that we're achieving. And then also we're coming in, taking yield measurements, and then from those we're also going to analyze the crop quality that we're getting at different parts through the field. So what the research is often showing happens with continuous flow is that you end up with a profile that looks something like this. Where this part is all full of water. So you've been successful in filling the root zone, which is great. That's what we want to do. But on a part of this field also we've overwatered. We've got all this water that's beyond the root zone. It's not really doing us any good, and in some cases can actually do some harm. And also after the end of the field too, this water here isn't really doing us any good either. The tailwater's coming off the end of the field. So you can see some areas that optimization could help out, yet not negatively affect their crops. The other thing I like to think about with this particular drawing is with this line here. Well, say we had a drier year and we couldn't put this much irrigation on, and so we have to shift that line that direction. Where our ability to irrigate that entire root zone is now more limited, and we actually might miss some of our money-making root zone here. Now, what the research is suggesting with surge irrigation is that you can end up with a soil moisture profile that looks something like this, and it accomplishes this through a series of surges or pushes of water down the length of the field. It's typically set up in quarters down the field, where your first surge covers out to about your first quarter, and the water's cut off. The water can infiltrate in, and as the surface begins to dry, it actually has a sealing effect on the surface, which is important for each surge after. So when you send your second surge to your halfway point, most of your water flows easily across the first quarter and ends up in that second quarter where you want it. And the same goes on with our third and our fourth surges. If additional depth is desired, you can run soaking surges after that, where water is run most of the length of the field, and those will actually continue to push the water deeper into your soil moisture profile. So in the correct scenario, we can see how surge irrigation can really help you make your water go further. We can eliminate this deep percolation that we have going on here, and we can cut back on the tailwater we have going on there. But also, often the studies are showing just that your uniformity across the field is significantly improved. Now, with any of these irrigation technologies we've been talking about today, there isn't a silver bullet. There's not something that's going to work the best every time, every place. You know, there's going to be scenarios where continuous flow is going to be the ideal situation for that operation. And there's going to be areas where surge flow is really going to be able to have some benefits. And because of this, we're doing this research on multiple farms here in Utah to see the positive effects that it might have.
So there's some really cool research out there, and we think there is good potential. And next year we'll have results that'll draw a good comparison between continuous flow versus surge. We're also, I mentioned.
Hey.
Oops. There we go. I mentioned we're also looking at some different scheduling adaptations. This is working with a farmer down in central Utah. His traditional plan is for his first cut of hay, he irrigates twice. For the second cut, he irrigates it once, and for the third, once again. And so our question was, well, what happened, you know, on a dry year, where's your best time to cut back if you had to? And so this year, what we're testing is on that second irrigation for the first cut. So that second irrigation, you can see the part of the map that isn't shaded there. So that just represents that very west set. We left that unirrigated. And we only have one cut of data off that so far. Second cut will be coming off this week. But in that first cut, it actually did reduce yield a little bit, about 0.14 tons, which would have been about $23 an acre. So it is pretty significant. So that's something that we're doing some research with him on. And I mentioned we're trying some new technology, and some of you've probably seen this. You can't actually see it in the video, but I sort of point to it. But each of these wet stakes, they have a name to help you identify them. And this one in particular, this is Violet. So I'll tell you what she does here.
So one technology we've been working with this year is called the wet stake, based out of Idaho. This one in particular, her name is Violet. And what Violet does for us is there's a built-in sensor in the bottom to sense when water reaches it, at which point it then sends you a text message. And it's a very simple thing to set up in the field. You just peg it in like that and turn it on. It's got a solar panel on top that maintains its charge the entire season. And the sensor in the bottom is calibrated so that every time it rains, you aren't getting a text message about that either. So the biggest complaint that we've got about the wet stake or similar systems typically comes from the spouses of the irrigators. They get a text message from Violet or Elizabeth or Candy in the middle of the night, and they're up and gone. Now, there is one perk that you can get built into the wet stake, and that's a humidity sensor. So on a night where you're not sure if you can go bail, you can text your wet stake and find out what the humidity is in the field, potentially saving you a trip and waking up your spouse for no good reason.
So what we've been doing with these is we give them to a number of the farmers we're working with to try them out and see if it helps reduce their trips to the field, or if it helps them shut their water off sooner. So we cut back on a little of that tail water. You can also see it could be helpful setting up your surge irrigation where you need to know when you're at each point of the field. So that's what we're doing with those. Now we're going to shift gears real quick and talk about pivot wheel tracks. This one you're looking at here, this is a little bit on the extreme side. This isn't typically what we see, but anyone who has a pivot knows how big of a pain in the butt wheel tracks are, whether you're bouncing across them or trying to cut hay around them or whatever it is. So we started just looking at a couple simple options to improve the wheel tracks. This is kind of your standard wheel track. This is our untreated control. There's nothing done here to improve the wheel track. And you know, on the left picture there, you see I'm standing 30 feet away from the tower, and that wheel track still got standing water sitting in it. And that just progressively gets worse through the season. So some of the things we're trying, this is an idea from Comet Irrigation, and their idea, you'll see a whole bunch of boombacks. A lot of the time you just see boombacks on one side of the pivot, and what Comet's idea was to put boombacks on both sides. And so they take what that one outlet is rated for and split it between those two heads. Their idea, I guess, is just to maintain your uniformity and to get less water in the wheel track just by spreading it out. And so that's one thing we're trying from Comet. You've seen these in Tina and Boyd's presentations, the LIPA, the low energy precision application. And we've had mixed results with these, but something we consistently saw was that it left pretty good wheel tracks. So what we did here was on the outlet on each side of that tower, we converted it to LIPA. So we split it up to the 3 drops with the low drift nozzles. You can see we've got some different pads, played with the pads to find a good combination for right there. But that's all we changed. So like the second sprinkler in, you can still see the eye wob there, your mid-elevation wobbler. But I mean, looking at that wheel track, it looks like this is working fairly well, and we are testing yield also to make sure that we're not hurting yield alongside the tracks. And then another thing we're trying, and again, this is just using the outlets closest to the tower. What we've done is split the outlet between 2 part circles. One mounted straight down from the drop, and one mounted actually on the cart itself there, on the tower itself. The idea, we wanted to continue to get good uniformity. We wanted good overlap with the existing sprinklers on the pivot still. But we also wanted to, instead of spraying in the wheel track, spray as close to the wheel track as we could. And as you can see, the wheel track there is pretty decent shape, and both this and the LIPA option are pretty cheap and easy to do. So again, we're going to be testing yield, we're going to be measuring track depths, but those are a new study we're working on. And yeah, thanks to all the guys.